Hi there, this is Shubham Mittal from Decipher Technique. Today we will be discussing about the discrete time systems. It will be a review of DSP for advanced digital signal processing. So what is a discrete time system? A discrete time system is a device or an algorithm that operates on a discrete time sequence to yield another sequence according to some well-defined rule. So here we say a device or an algorithm. So it can be hardware realization or a software realization of a system that operates on a discrete time sequence. A sequence can be xn, like it is shown here, and it will yield another sequence yn. So this sequence which is fed into the discrete time system is said to be input signal or excitation to the system, and what we get out of the discrete time system is the output signal or the response. So how do we characterize such a discrete time system mathematically? We are concerned with the terminal characteristics only. What we mean by this is that if we are having a system S, we are just concerned how a discrete time sequence fed into the system is transformed into a new sequence like this. So we are just observing the input terminal and the output terminal of the system. We are not concerned about the internal characteristics of the system. We are only concerned with the terminal characteristics of the system. We ignore the internal structure of the system. So we can say that xn is transformed into yn. So this transformation is denoted by t. It can be seen as an operator which transforms xn by application of t transformation. So the input output description can be mathematically shown like this. Xn fed into the system is transformed into yn by an operator t. Let us see some examples of discrete time systems. The first and the foremost is the identity system. The identity systems are the systems which pass the input unchanged. What we mean by this is that if we input a sequence like this, then the output sequence will be identical to the input sequence. Yn is equal to xn. The unit delay system. The unit delay system delays the sequence by one sample. We can have a k delay system likewise, whose mathematical description will be yn is equal to xn minus k, where k samples delay are applied to the signal input sequence. Unit advanced system means yn is equal to xn plus 1. So we are getting the corresponding samples with an advancement of one sample. So it will be yn is equal to xn plus 1. It means if we are to find y1, then y1 is equal to x2. Then we have moving average system. The moving average filter takes the average of the corresponding amplitudes on the left hand side as well as the right hand side of the current sample. Here we have a moving average filter with a span of 3 samples. With a span of 3 sample means if we are to find an output at this value, then we are seeing the previous sample as well as the next sample and the current sample. So we have a span of 3 samples. We can generalize this moving average filter by a m sample moving average filter, where yn can be written like this. The yn can be written like this: 1 upon 2m plus 1 k is equal to minus m to m x n minus k. So it will take the previous m samples as well as the upcoming m samples as well as the current samples. So there will be 2m plus 1 samples and we average out those samples. Then there will be a median filter. Here it is a median filter consisting of 3 samples. One is the next sample and the previous sample and the current sample. So it takes the median of 3 samples. Accumulator, what accumulator does is it accumulates all the previous values up to the current value. So if we are to find the value of a sample at an instant n, so we sum the current input as well as the past inputs. This is the definition of accumulator. Let us input an example sequence to all these systems. Let us we have an input which is infinite duration sequence having coming from the minus infinity, n is equal to minus infinity. Here we have pivot n is equal to 0. This is n is equal to minus infinity this side, and n is equal to infinity this side. So we have 3 2 1 0 0 1 2 3. This is the input sequence. So the identity system will produce the output yn identical to the input xn. This is the sequence. Unit delay system, what it does is the occurrence of every corresponding sample will be delayed by one sample. So what we were getting, sorry, here this is not, this is not the n is equal to 0, this is n is equal to 0. This x0 will now occur at x1. This x0 will now occur at x1. So it is delayed by one sample. So we have pivot at n is equal to minus 1. This is n is equal to minus 1. So we have shifted the pivot or the origin of the sequence. Likewise, the unit advanced system, the origin of the sequence has been shifted to right. So whatever samples we were getting, we are getting with an advancement of one sample. Now we will see moving average filter. The moving average filter takes the three samples, one on the left hand side and one on the right hand side. So like we can see at n is equal to 0, the output should be 1 plus 0 plus 1 upon 3. So it is 2 by 3. Likewise, all other sample values can be calculated. The median, the median output has considered this window for computing y0. This is y0. This is y0. So y0 is calculated as the median of 1, 0 and 1. So we will first arrange in the ascending order 0, 1, 1. So what is the median? 1. So here we write 1. Likewise, we can compute the other values of the output sequence. The accumulator accumulates all the previous values up to the current value. If we just assume that the previous values were 0, then this n is equal to minus 3 at this y minus 3 is equal to 3. Then we accumulate the second value to it. So 3 plus 2 5, then 5 plus 1 6, then 6 plus 0 6. So this is y0. Likewise, we keep on accumulating the values of the sequence. So this was the quick introduction into the discrete time systems. How do we characterize and what are the most common discrete time systems used in the digital signal processing. Thank you.